What's up, guys? Welcome back. I will be also turning this in on. I'm gonna be turning this in for a grade for my geometry class. So those of you watching this on YouTube, don't worry. The answer and everything signing, like everything, like the answers and stuff. That's gonna be at the end. Don't worry. So this is a walkthrough. For those of you on Flipgrid, don't judge me. I'm doing this YouTube style, please. So it's just easier so that way I can get a video up and I can get my grade in for geometry. But anyway, let's forget about that and let's start. So basically what I'm doing for my project is I'm going to do a walkthrough on how to do calculate surface area for this 3D composite shape. Basically what the task is we're building a rocket. Don't tell North Korea. But essentially the measurements in millimeters. So one more thing I would like to do is that in your mind change millimeters to feet so that way it's a little bit to scale. So basically what you're going to want to do first, I'm going to have to tell you something. I'm just going to tell you the measurements of this triangle because let's be honest, you'll never be able to get this. 2 feet essentially. Holy crap, this is not to scale at all then. Whatever, just still do feet. 2 feet right here is the thickness of the prism. So essentially what you're going to want to do is you're going to want to find the area of all the shapes and add them together, and that's the area of the composite shape. So really I'm just going to give you the cylinder and then you'll have to figure everything out by using the cylinder. The cylinder's height is 75 and the diameter is 20, but that also means that the radius is 10. So the cone is 2/3 of the cylinder. I'll put that in a giant text across the screen right here. There we go. And if that's the case, then if this is 2/3 of the cylinder, then the triangles for the height is 10 less than the cylinder, and across over here is, I'm thinking it's 10 less of that too. Let me double check. Yep. So with all the information I just gave you, try to see if you can find the measurements of these shapes. I'll give you a second to do that. I'll tell you this next clip. So in the meantime, just pause during the intermission so that way you can try to... Alright, now that the intermission's over, or whatever you want to call it, so essentially you're going to want the measurements to do anything beforehand. So 2/3 of 75 is 50. And how you get this is that you put 70 times 2/3 in your calculator, I'm pretty sure. It works with mine, you just get 50. And since it's all uniform, the diameter is also 20 for over here. And when I meant 10 less than the height, that means the height of the triangle is 40. And yeah, the side is 30. So what you're going to want to do is find the area of all these shapes and stuff. So what you're going to want to do is find the area of the cone. I'll put the surface area of how to find the cone down here. The trick is for one of them, you need the slant height. Just here's what you're going to want to do. Boom, it's a 2D shape now. Well, not really, but like what you're going to want to do is right here, you're going to want to divide this, so that means it's 10, and then make it into like a perfect right triangle, and then you're going to want the height, which is 50. The reason you're going to want to do this is because you're going to have to use the Pythagorean theorem. Yeah, a bit complicated, but still. So you use the Pythagorean theorem to find the slant height, because that's how you find the hypotenuse of a right triangle. I'll put the formula for the cone up here if I didn't already, and it should be up there for quite a while. And then, yeah, so you just find the surface area of the cone. And then you move on to the cylinder, really. Well, we were supposed to do that first, but I just wanted to get the cone out of the way because cones are... Okay, area of a cylinder. That is actually really easy. A lot easier than a dang cone. Because cones are essentially they're really round pyramids. Pyramids with the circle at the base. That's what a cone is. So, the area of a cylinder. You see, cylinders are a lot easier, but the surface area complicates everything even more than the lateral area does, because, you know why? Math, that's why. So, I'll put the formula up here for the area of the cylinder, but it's 2 pi r times height, which is technically, so if I were to say that in actual numbers instead of using letters, that would be 2 pi 10, because 10 is the radius, 20 is only the diameter, times height, which is 75, plus, here's the rest of the formula, 2 pi 10 squared. You literally just type that whole thing in your calculator and you'll get it. I'm not even joking, and that's the measurement of the cylinder. And this triangle, it's not rectangular, it's a triangular prism. They are they're a lot easier than round shapes, in my opinion. They're more complicated to do because, you know, I guess in my opinion, but I still find them a lot better than round shapes. So that's a triangular prism. So that would be the perimeter. So what you're going to need to do is use a Pythagorean theorem to find all the sides of this triangle. Just imagine that it's a 2D triangle. I'll make it easy for you. So you do that. So you got 40 and you got 30. I'll put the Pythagorean theorem formula up here. A squared plus b squared equals c squared. So you square 40, you square 30. And then you add them. And then you put the square root of the number that you get, and that's how you get the hypotenuse. So then since you got that, you also got to get the quote-unquote height. And you already know that. That's 2, because, like, you know, the thickness. And that's plus 2b, or plus 2 times the whole the area of the base. So at this point you don't need I'll put the formula up for the area of a triangle anyway, but if there's 2 that you need to solve for, then you don't have to divide by 2. It just makes things easier, but if you want to divide by 2 and then multiply by 2 again, that's okay. That's usually how I do things. Okay, so here is the Word document with the answers. If you did this right, you got 1916.4 for the area of the cone, 5340.707511, or if you want, you can just simplify it to the nearest tenth or hundredth. I like exact answers though, so. And now 440, I'll explain why. I got the area of the prisms or the fins, and I multiplied that by 4 because there are 4 of them. You don't need to do the math for each individual one because they're the exact same. Same everything. Same face, same sides, exact same measurements, and I can prove it. I'm just not going to, because I don't want to go back to Tinkercad and actually show you. So then you add them all up, and then your area is 130.17.10751, and that's the total area of the rocket. 13,017.10751 feet squared. That is a big rocket. So yeah, if you're on YouTube or Flipgrid, doesn't matter, like and subscribe to my YouTube. And I hope you guys learned something, because this is helping me get my video quota up for YouTube, so at least that's good. If you learned something, great. If you didn't, I'm sorry. But I really hope this video helped